All right, guys, we are going to start Unit 1, Chapter 1, Section 2, Linear Measure today. Today's objectives are just so that we can measure segments and then we can calculate with measures. So, again, we're going to start with a object and we're going to describe it and we're going to name it and then we're going to show an example. So today's object is going to be a segment, which is a part of a line with endpoints. So remember yesterday we talked about a line goes on indefinitely in the directions, and so a segment is just part of that. So it's named by its endpoints, and this is going to be 2 points, and so this is just like we could label our line yesterday with by 2 points, but the way we do this is going to look slightly different. So if we have a segment today, and we have it with M and N, see how it does not extend past the points and have arrows? And so this is our segment, and so we're going to have M, N, and we draw just a segment above it. If we have a line, just show you the difference with M and N. Here we're going to draw a line above the MN with the arrows showing that it goes on forever. So let's talk about, can you find the length of a line and explain? And when we talk about a line, remember it goes on indefinitely. So no, we cannot, again, because it extends indefinitely in both directions. And so a picture, just to remind us, has the arrows on the ends. It means it goes on indefinitely. All right, so can you find the length of a line segment and explain? A line segment is different. It has a start and an end. So we say, yes, we can because it has a start and an end. All right, so moving on, we're going to actually find the length of segment AB in each diagram. And so if we look here, we have centimeters, and this one, our endpoint B, doesn't quite go to the 4. It ends about there. And so we are, instead of saying it's equal to, we're going to use the squiggle ones and mean that it's approximately. And here if we count, it's 1, 2, 3 centimeters, and it looks like we could say about 0.75 or 3/4 of a centimeter. And don't forget that label on there. Now if we look at our B, our second AB line, this one has smaller hash marks in between, and if we count up our lines in between, we'll count that there are exactly 10 lines in between our 3 and our 4. There are 10 lines between our 2 and our 3, and there are 10 lines between our 1 and our 2, and 10 lines between our 0 and our 1. So we're going to say that our centimeters is broken down into 10, and so we can count and make this a fraction. So if we count again, we have 3 full centimeters. And if we count, we have 1, 2, 3, 4, 5, 6, 7. The little dot ends above 7 out of 10 centimeters. And we can keep this one as an equal sign because we are going to the exact line, whereas in A, we only went approximately. Now, since it's out of 10, we can also write this as 3.7 centimeters by changing it into a decimal. Okay, so if we look at number 2, it says find the length of our segment RS in the diagram before. Now if we look here, we're dealing with inches, and so our label is going to be in inches. And if we count between 0 and 1 and our 1 and our 2, we will find that this has 16 hash marks. So again, in this case, I want to count. We have exactly 1. And if we count over, we have 1, 2, 3, 4, 5 over 16 of them. So we want to say, in generally, when we are talking about our measurements, centimeters are in tenths, and inches a lot of times are broken into eighths or sixteenths. But we always want to just keep in mind that that could be broken down differently, so always count before you make your fraction. Okay, so here we have number 3, and I'm going to have you guys do number 3 on your own and bring it back for class tomorrow. So careful how many it's broken down into. All right, now we're going to talk about betweenness of points. Betweenness of points is best described by looking at our picture that we have here, and we can say S, which is our point S, is between R and T. And we're not saying that it's exactly between, it's just somewhere in between the points R and T. Okay, so we're going to keep that in mind when we're looking here, for example, at problem 4. It says find the length of segment XZ in the diagram below, given XY is 4.5 centimeters and YZ is 3.2 centimeters. So let's go ahead and draw this into our picture, the information that we do know. So XY, which is our first segment, we say is 4.5 centimeters long. And our second measurement they give us is YZ, and YZ is 3.2 centimeters long. Now we want to go back and make sure that we answer our question. It says find the length of XZ. That's the entire measurement that we're looking for. Okay, so we are going to say that segment XZ is equal to our 4.5 plus our 3.2. So if we add those, that's going to give us our measurement for segment XZ of 7.7 centimeters. Don't forget that label because they did give us labels of centimeters up in the original problem. All right, so let's take a look at number 5. 5 says find X and ST if T is between S and U. ST is equal to 7x, SU is equal to 45, and TU is equal to 5x minus 3. It says draw a picture. So let's go ahead and draw a picture similar to the one that was given to us on our last problem. Okay, it says it says T is between S and U, so S and U are our endpoints, and T is somewhere in between. It doesn't matter where we say T is, it's just somewhere. Okay, ST, so that's our first measurement, is 7x, and SU, which is our entire line, is 45. And then it says TU, which is our last segment, is 5x minus 3. So here we need to find two different things. We're looking for what x equals, and we're looking for ST's measurement. All right, so I'm going to let you guys finish this problem and bring it back for tomorrow. Remember, you need to find x, and then don't forget you plug that back in and find out what segment ST is equal to. So we've got the drawing done together, and now you can do the calculations on your own. All right, so let's look at number 6. Number 6 says find the value of a and xy if y is between x and z and xy equals 3a, xz equals 5a minus 4, and yz equals 14. So let's go ahead and we'll draw this picture together. I just want to make sure that you're getting your diagrams done correctly so that when we get together and work on our homework, that you guys are going to be great at them. Okay, so y is between x and, ooh, that should be x and z. My apologies, x and z. All right, so if y is between x and z, so let's go ahead and draw this picture. So we have x at one end, we have z at the other, y is somewhere in between. All right, xy is equal to 3a, and xz, that's our entire segment, is 5a minus 4. And then it tells us that yz is equal to 14. All right, so we're looking for two things here. We're looking for the value of a, and we are also going to look for the value of segment xy. So I want you to go ahead and find out what a equals. and then substitute that back in to find out what x, y is equal to. So you can go ahead and finish this problem for homework tonight, and then we'll come back tomorrow to talk about it. We have one more thing we're going to look at in this section of notes, and we're going to just talk and touch base on congruent segments. Okay? Oh, that wasn't supposed to happen. There we go. Congruent segments. So if we look here, we have two segments. We have segment MN, MN, and QP. All right, so I'm going to fill in that MN, segment MN, is congruent to, that is this symbol right here that we read is congruent to PQ, segment PQ. Because segment MN and segment PQ have the same, well, if we look here, they have the same measures. They have the same measure. So keep that in mind when we touch base tomorrow and when we're looking ahead at our homework, that congruent occurs when we see the same measure. That will happen in lines, and it'll also happen when we get looking at angles. So don't forget to go back and finish problem 3, problem 5, and problem 6, and we'll talk tomorrow.